She wrote 13 over 8 divided by 8. That's what you were saying, right? And then when you asked her, did I teach her this? And then she said yes. I think this is a misconception because number one, division of fraction is not in our P4 syllabus, so there's no way I could have taught her this. Okay, and yeah, she did do the correct long division. Okay, she actually took 13 divided by 8 to get the answer. I think maybe she just made a mistake by writing this divide by 8. Yeah, because I am pretty sure I did not teach any one of them to write divide by 8. Yeah. Yeah, because they have a tendency to copy each other. You know, when you do pair work, it means, okay, it's time to copy my friend. So that's what they do sometimes, you see. Yeah, so...
clarify this misconception. I understand that they know that this is because both of them actually were doing something, and I was watching them.
Okay.
Separately.
Yeah.
So this concept probably. Okay. Because I was watching them doing the same thing, and there was this thing that was blocking them. So they were actually doing the same thing when arriving at it. I find it very interesting. You know, that's why I raised it up. So this concept, I was asking one of them, and this girl, Jia Xing, seems to be the one that's leading the other girl. Yeah. So that's the reason why I brought this up. So I think, probably want to address something like that.
Okay.
Maybe in class also, use it as an enrichment or something like that. Yeah, saying that this.
Because when I mark their work, I don't see that in their work. This divide by 8 thing, because it was never introduced to them. I don't know, maybe they could have gotten it from their tuition teacher or their mothers. I don't know, whatever. So that's why they have this. But yeah, thank you for highlighting this this divide by 8 so I can address it. Right. Thank you.
Yeah, just want to share something. I thought this part here of the use of the manipulatives was very nicely brought out. The students could actually see physically that the wrong answer and the correct answer is actually totally different. And I thought when the teacher actually showed this too, there was some spark in their eye, and they actually got to realize that, oh, actually if I do it in the wrong way, compared to I do it in the right way, I get two different answers. And I thought this was actually very nicely brought out. And I also thought that this part here, this analogy where he used 1 cm plus 1 meter equals to 2 meter, this was also a very good form of get them to think that I cannot add two things that are not of the same unit. I thought this was very good. And in fact, actually, I thought this could actually be brought up at the start of the lesson already, to get them to see that fractions of different denominators cannot be added together, just like I cannot add 1 cm to 1 meter to get 2 meters. And another use of manipulatives maybe I can suggest is that you get them to, on their own, get them to hold 1/4, and then you get them to add 1/8, like this. And then you ask them, can you tell me what this fraction is? And then they will think for a while, and then they realize that actually they cannot give you an answer because they can't count the number of equal parts. Yeah, then you get that from there onwards, you can stress that, or what is the meaning of fraction? A fraction is actually parts out of a whole, and every part is the same size. So then then you ask them, how then can I count this part here properly? Then you introduce the concept of equivalent fraction. Then you get them to see that 1/4 actually I can convert it to 2/8. Yeah, thank you.
Thank you. Okay, I just want to address the one on no models. Okay, what is it? So because yesterday after the lesson we realized that they were converting from a pi to a bar. They were like, how do you relate that, right? So since our objective of the lesson is supposed to getting them to use manipulatives, I mean, not really like, as you said, CPA can be, you can go back to the P, you can go back to the A anytime, but ultimately we really want them to explore the manipulatives to get them to see the conceptual understanding behind this adding of fractions. So we decide to drop out the models in the question. So if you realize the question paper, there's no model mentioned at all now. So that's exactly why the pupils did not, the pupils are like really reading the instructions or instruction set must draw model. So in their mind, models means in the textbook, models are the bar type. They've not seen models that are of the fraction this type. So that's precisely why we thought that, after all the confusion yesterday, we didn't want to introduce the confusion in today, so we decided to take out the word model. Okay, that's one. The other one is changing of improper to mixed number. You mentioned that many of them leave it as that way. Okay, basically, I think they've already taught how to change it. But in this case, I mean, if they're solving a word problem, even if they leave the answer in that way, we don't penalize them in exams. And them being in a weaker class, if they can get an answer correctly, we'll be very happy, to mark them right. The marks will be awarded in exams. So the main stress here is not for them to convert to mixed number. So if the question specifies that you have to leave your answer in the simplest form, convert to mixed number, they will automatically do that. But in the questions here, we did not tell them to do so. So that's probably another reason why the children are happily just leaving it, because as long as they can arrive the answer, they're very happy. So in fact, some of you were saying that they were stuck at 20, 10. Is it 2 whole or is it 1 10 out of 10? So we'll pick that out. We'll reinforce on that in another lesson. But today's lesson is basically to get them to add up the two different fractions, changing them to the same denominator. Yeah, thanks.
Well, definitely we want to continue this discussion. But I wish we could have 30 more minutes. We could have much more discussion. But and also I can talk more. Well, I try to summarize. So now the law is changing. And well, thank you very much for the team. This is the end of the post-lesson discussion. Thank you. Okay, so now I'm a different jacket. So the final commentator. The first of all, it's as team emphasized, it's very. They try to reveal student misconception. That's why ask students to use these manipulatives. As a result, we see a lot of struggle, right? Even though they calculate it, but they cannot articulate. And well, some of you say they can calculate, why it's problem? But if they do not understand conceptually, what's going to happen? Multiplication of fraction, division of fraction, using fraction for ratio and rate. So they're going to be stuck. So already this grade 4 student, so even though the team say this student is not high, but it's not very, very behind, right? It's kind of little below, but still a lot of students may not articulate. And this is a very serious problem. Where is coming from? As you said, younger grade teachers, they skip this important process, concrete and then pictorial. Because they don't have time, I just tell them to do so. It's fine that moment. They are very good students. They follow what teacher said. And they don't want to embarrass teachers. So they are very concerned about teachers. Well, it's opposite, right? We should concern student. But students say, well, I understand, I can do this. Then skip, go ahead. Then accumulation of these misunderstandings. And then these students is falling apart. So I think I'm very happy that that this team, even though students superficially calculated, but to dig into this one. And again, yesterday I said, many teachers do not do this because you don't want to see students struggle. You don't want to see your student misunderstanding, misconception. Therefore, just tell them, oh, don't worry about it. Just do it. Level 1 teaching. If you stay with level 1 teaching, you are a very happy teacher, right? Then just tell student, if they do not do this, you are a bad student. You blame student. But it's not our job. Well, our job is to help them to really understand. That's the purpose of public education. That's a human right. every single student in your country have a right to understand basics. The teacher's job is to provide these basics, help them. So we need to do this. Right? So therefore, I really admire your effort. And because of your effort, we share this moment. We see how students struggle. It may not be able to see you teach every day. You are busy, very busy. But once in a while, you have to have this opportunity. Well, there are some, some issues that come from your, the discussion. For example, 1 by 2. Casually, students say 1 by 2. What does it mean 1 by 2? 1 divided by 2, right? Which is another meaning of fraction. Fraction as a quotient. I talked with you the day before yesterday, right? Which is very abstract. Right? Part of whole meaning, this is 1/2, right? Or 2/2. That's a part of whole meaning. 1 by 2 is a different meaning. So we need to be careful when we teach language. If the language does not attach to conceptual understanding, it's meaningless. We teach vocabulary. Vocabulary is important. But when you teach vocabulary, please be careful. What kind of conceptual understanding attached to this vocabulary? The vocabulary is only a visible part of big iceberg, right? If this vocabulary does not attach to strong conceptual understanding, they do not understand. They cannot use properly. And also, this is the various terms today is used, denominators, or numerators, or even students say same, right? But what do you mean by same in this situation? In the mathematics, same or equivalent have a specific meaning. If you in the mathematics, we should use mathematical language. And then that is not just teacher use it, but students should see, well, this in the mathematics classroom, we have to say this way. In the mathematics classroom, we have to say 1/2 or 3/4, right? Not, like 3 by 4, something like that. They may use in everyday life, right? But be specific. And that is important. Okay, another thing is that today's, some of you said compared to yesterday's lesson, today's student confident using manipulatives. However, nobody draw this picture, right? That's the important observation. Why do you think students do not draw? The circle is not easy to draw, right? If you square or rectangle, if you give this grid paper, they can write. Right? And then even though like yesterday student misunderstanding that the whole size of whole, well, you can help them to realize, oh, this doesn't make sense. But circle, you cannot draw. When you try to draw, it's always about. Fraction is not about. Fraction is a number. The specific, the address on the number line. So we should help students. Fraction is also the number, not always about. Not about half, not about 1/4, something like that. In order to do so, we should, at the beginning, maybe you could use this circle, but away from this. This is very good tool for part whole picture. But there are some drawbacks, and I'm going to explain a little bit later. Let's see. I have 3 papers to talk to you, so if you don't mind, I can talk a little bit longer, okay? Because this is very, I learned a lot from my observing lesson, and then what is the issue in the Singapore student, and then what is we need to consider. So my brain is kind of burning. Let's see. Okay, first of all. The use of manipulatives. Why this is, how we should use it. Well, any manipulatives, if you use effectively, student overcome. But just giving a manipulative may not be so helpful. Remember the very first, the boys that they sit down, come here to show this one, right? and then he could not articulate. And do you remember what he did was like this first, right? And then do this, right? And then he can try to move this one. In my guess, he tried to do this because half and half makes one, right? Then this one. Then this is 1 and 1/4. And many students like to do this. Do you see that? And then some students using whole and then 1/4 replace it. This is answer, right? And as you said, you point out very important things. You can add these two pieces, right? This is the amount pizza you get. This is the answer. If you use manipulative, this is answer, right? So this is the amount I got the pizza. But what problem is how to express this one using number. How to show this amount by using number, in this case fraction, right? Representation is a problem. So finding a total amount is not that difficult. You can use it. That was not so clear for students, right? And then this process, there's no conversion. You don't have to change number. You don't have to change denominator. Just put them together and then 1/4. So therefore, like, what's the problem? Students do not see the procedure and then this manipulation. If you do not see it, it's not so powerful. So how can we help students to see the relationship between the procedure and then this? Probably this particular number is not so good because 1 and 1/4 is so clear. You don't have to convert anything. But actually, the procedure is just as he tried to do at the beginning. Instead of 1/2, you put 1/4, convert to 2/4, right? Now you have 1, 2, 3, 4, 5 quarters. I can express by using this. However, in this particular case, just 1 and 1/4, that's answer. Without converting, answer can get it. So the selection of the number might not be so useful to students to see how we could use this manipulative to explain your process of calculation. So that's probably if the student struggle. I think that the student try to say, oh, this is equal, that's 2 of 1/2, therefore 1, and then 1 more. If we push something a little bit more, he could articulate. And in fact, he's a good student, right? He can calculate very quickly. But he cannot, I was curious about this student, and then go back, and then he very quickly calculated, but do not see maybe seeing the connection, but you cannot articulate. So, well, that was, I see. Another one is the Kai, the girl over there. And then there was second problem, 1/2 and 3/4. She did some very interesting things. Not 1/2 and 1/4. Let's see. 3/4 plus 1/8. So the second problem, 3/4 plus 1/8, right? So she used this one, 7/8. Can I steal your? Sure. I need your birthday present, so I need permission. Let's see. 7/8, right? So use this board to put these two. Right? And then like that. So again, this approach does not require any conversion. And also this is 1 and 8. So let's see. But if you go further, how much? Well, this is mixed together. So you said I don't like to have a mixed size of pizza, right? So in that case, you need to convert 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. Then you're going to convert this one to whole, and then 1 and 8. So all this process, we should, the one-to-one correspondence to the calculation, and then manipulatives. That is a concrete, pictorial, abstract process. Not just finding answer concrete, finding answer pictorial, finding answer abstract. You need to see the one-to-one correspondence. What does it mean? What does it mean in the pictorial? What does it mean in the concrete? Why this is so important? Because if you got even high school, if you see the problem, and if you cannot solve abstractly, what you should do? Even mathematicians, they draw picture. Right? It's a pictorial. Right? And sometimes you need to do some actual experiment. But that's useful. Of course, you understand all these equations, but if you are not sure, go back to drawing and then see, oh, that makes sense. I can use it. Right? So you should be able to back and forth freely, these three. It's not just helping student to go through one way. Every single student should be comfortable in any ways. And then if you try to communicate with a friend, and then friend do not understand the idea by using equation, what you gonna do? Draw a picture, right? Then communicate. So it's a communication. And therefore, the conceptual understanding is quite important. If you do not, cannot communicate with equation, if you do not know how to draw it, you have to give up. But it's not a good idea. Okay, so let's see. So that purpose, that process you should, oops, it's more. Okay, next one. There are two problems, but I wanna discuss the second one, 6 plus 7, 8 plus 8. So the 16, oh, this one, right? 16, I think that you spend so many time writing. This is very, but this 16 is not this 16. 16 in this is different meaning. Do you see why this coming? Where this coming? This is 3/4, right? 3/4 plus 7/8, right? 1, 2, 3, 4, 5, 6, 7, right? And then this is 3/4, but you gonna convert this one. So at 1, 2, 3, 4, 5, 6, right? 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6, 7. Sorry, I cannot count. I'm not a good math person. Okay, so this is 6 and 7. Where is 16? 16 is the total number of pizza. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 16, 18. 16. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 16, 15, 16. Thank you very much. I have a long week. That's the 16. Okay. Please deal this problem. some of you picked up. And I realized today, but yesterday's problem too. I did not realize yesterday. So what is in the worksheet? Please read. This can be whole, right? If this is a whole, this is right. Right? But if you say what fraction of a pizza, pizza, in this case maybe 13/8. But the tricky part is, if you say what fraction of a pizza, this is not a pizza, right? It's already beyond a pizza. That confuses student. Right? Do you think pizza is a good model? Right? I think we should go linear measurement. What fraction, show the length in meter is much more straightforward to use this. Or what fraction, the measurement context is much more. Student may, what fraction of a pizza? This is not beyond 1. And also, if you say what fraction of pizzas, this is right. Right? So, I think also we need to think about it. Of course, textbook use pizza in the Singapore textbook. I don't know why, but Singapore people really love pizza. And then American people really like pizza. They use pizza. Well, actually, I say, during early 70s, if you look at the early 70s textbook in Japan, there are some pizza diagram, circle. But right now, no textbook use it. So all this measurement context. So linear measurement, because linear measurement is much closer to number. And then also diagram. Okay, so one more important thing. Let's see. From this, you may be able to add denominator. Right? In this case, you can add 16. But today's lesson was so much emphasized on you cannot add denominator. You cannot add denominator. But today, if this is of a pizza, adding denominator does not make sense. Therefore, we do not want to add. We do not want to add. Right? Because it doesn't make sense. I think that's the correct. Because we can calculate, we have to calculate. We have to do something in the denominator. For example, if you 7/8 multiply 3/4, what we should do? 7 times 3, 8 times 4. Right? So then students say, well, we cannot multiply denominator because elementary school teachers say you cannot do for the denominator. They may say that. Why we do? Because we make sense. In this case, we need to change the size of unit. So, for example, I showed yesterday, like the day before yesterday, right? Oops. 7/8, and then 3/4, right? Oh no, I'm tired. Sorry. So this region, in this case, you need to change the size of unit to, this is whole, and then this is 1/8, this is 1/4, but now we use this as a unit. So therefore we multiply to find the unit, right? By the way, let's see. Let me change number. Let's see. Do you think this works? Let's calculate. 2, right? This is 2. Oh, no. Yeah, it's 1, right? So, okay. So you may be happy. This, right? This works. You can generalize. You can you can generate. It works for all the time. But we don't teach it. We teach this multiply inverse, but this actually works. So when we say you cannot, we should be very careful. Mathematically, sometimes you can do that. So we need to think about it. And well, you could, if you are interested, I can prove this one, but anyway. So even do not in a textbook, even we do not use it, but sometimes correct. So you cannot, or you should not, please be careful, because students sometimes that stays student head, and then that is confused student when they become older. So today, denominator, you cannot add. We do not want to add because it doesn't make sense for this situation. Anyway, so many things, believe or not, just one lesson and yesterday, 2 lessons. How much you can learn this, right? That's a lesson study. By looking at the student, we are very concerned about our student. Therefore, we are serious observing lesson. We seriously plan the lesson. We seriously discuss lesson. We seriously summarize this lesson. This is definitely learning opportunity, right? And then also, people say, well, this is a teacher-led professional development, and then knowledge may not gain, but it's not true. If you observe a student and talking about, probably discussion today stay with your head. Just like hands-on activity for the student. Pictorial, concrete. We see the very concrete situation. And then talk about abstract. So, but because of this, because of your effort, we can learn a lot. So we really appreciate it. And then again, and then I have a gift for teacher who taught this lesson. So this is a t-shirt. So one life, one chance, right? Thank you very much. So because you are, the risk taking, so we can learn a lot, right? So one chance, one life. Thank you very much. Sorry, I talked too long, but I hope you don't mind, because we're gonna have a long weekend, right?
Come to the end of our lessons. First lesson, Study Leadership Institute. But on Wednesday, when I start this event, I actually introduce very briefly. Okay, what? Sorry. Okay, when I started this session on Wednesday. Microphone, okay. I also must use the microphone. All right. When I started this event, I actually introduced how this LSLI actually came about, and I actually shared with you that it was actually the idea of Professor Christine Lee, who is the head of curriculum teaching and learning from NIE, who actually had this idea, and he actually contacted Professor Akihiko Takashi and booked his time 1 year before, right? And we actually, it's very privileged that she's here, she rushed here from her lesson, from this morning's lesson to join us, and she's here today and she's going to close the ceremony.